All right, so let's talk about 3C.8 remainder theorem value and evaluating polynomials. Okay, this again is things you should already know, like how to multiply. I promise you, it's easy section. So we all know that we can simply evaluate by substituting given value for the independent variable. Okay, we, however, can also use synthetic division to evaluate. All right, now I repeat again, this is a shortcut. If you don't want to do it, do you have to do it? No. Okay. So if you look right here, remainder theorem says that if a polynomial is divided by a binomial, x minus a, which is in linear form, then what you end up the result is going to be that answer, that output. The remainder is the p of a, the output that you would get. So for example, let's say we have p of x equals x squared minus 4x squared minus 7x plus 10, and we divide it by x minus 2. Okay. If we solve x minus 2 for 0, we get p of 2. We get 2. We're going to plug that in, and that's going to be the output, right? Yes. So we plug in 2, get it? That's how I do it, right? Now, what the remainder theorem is saying is that if you do this and you have no remainder, then that goes along with the factor theorem. But the remainder theorem is saying that you can do the same thing with synthetic division. Now, again, if you don't like synthetic division, are you going to want to do it? No. But you can do the same thing with synthetic division. You still are going to take x minus 2, and you're going to set it equal to 0, and you're going to get 2. So you're going to take that, and you're going to plug it into the p. So we have p of 2, which is going to lead us to 2, do. And we're going to write out our coefficients, 1, -1, -7, and 10. We're going to bring down our leading coefficient. And we're going to start our engines. 2 times 1 is? 2 times 1 is? 2. -2 plus 1, -1 plus 2 is? 1. 2 times 1 is? -7 plus 2 is? -5. Right? Okay. I was like, what? I wrote something wrong. That's not right. And y'all just let me go. I was like, this doesn't feel right. Yeah, terrible. Just terrible, guys. Y'all let me write a 1 instead of a 4. Makes sense. -4 and 2 makes? -3. If you owe me $4 and you give me $2, you still owe me $2. 2 times -2 is? -7 and -4? That's not multiplication, it's adding. If you owe me $7, you're like, let me borrow another $4. You now owe me 11. And 2 times -11 is? And 10 and -22 is? -12. You see how you still get the same answer? Yes? That's literally what it's telling you. Okay, so we're going to practice it. So we have p of 3, and it wants us to find p of 3 using synthetic. If you hate synthetic, could you plug it in? Yes, but we're going to practice using synthetic. So it's telling us what our divisor is for the synthetic. Our divisor is 3. We're going to write out our coefficients. And I note to self that I'm missing 3. So I have 1, 0, -2, -1, and 122. And we start. What? That's not a 1. You see nothing. You saw nothing. I wrote the product instead of the 1. And 1. 3 times 1 is? 0 plus 3 is? 3 times 3 is? -2 and 9 make? 3 times 7? -1 and 21? 3 and 20? And 122 and 60. 182. So therefore, p of 3 equals 182. Yay? Nay? We're here? You're with me? All right. Your turn. By yourself. Go. You got it. I don't know if that made it any better, but. Remember, if you do not like this method, what's your other option? Substitute in. I don't know. What is this definition? I don't know. Like, we should say that. Negative 4 MC negative 3. Yes. This is negative 7. Oh God. Actually, what? Where are you? Then 12 plus negative. Wait, is it negative 12 or where did you? What? Where did you multiply it? This is what I'm doing. Okay. Is that wrong? How was that here? Hold on. Wait. What are you doing? What are you doing? Times negative 4. Oh wait, plus negative. Wait. You went wrong. Make sure you All right, time. Your group don't do consensus, so what you do? God damn it. She said dang it. Oh god darn it. Said dang it, recording. Bob. Flipping. Gosh, flipping freaking Pearson's favorite password. You think you did right. All right, here we go. So, as we did it, remember, if all else fails and you don't feel like doing this, remember, this is just function notation. It's just telling you where x is, it becomes a negative 4. But imagine if this is a shortcut to have them think, what is negative 4 to the 4th power? What is negative 4 to the 3rd power? What is negative? Do you see the ease of it? The ease of it? Are we buying into it or not? 1, negative 3, negative 28, 5, and 20. Okay, so we get it going. Bring her down. Negative 4 times 1 is negative 4. Negative 3 and negative 4 is negative 4 and negative 7 is positive 28. Negative 28 and 28 is negative 4 and 0 is 0. 5 and 0 is negative 4 and 5 is, and therefore the answer is, so we know P of negative 4 equals 0. Okay, going back to factor theorem, that means that if P of negative 4 equals 0, that x plus 4 is a factor. So tying back into our 3C.6 notes. But because this equals 0, that means x plus 4 is a factor. Oh my gosh, they're connected. That's crazy. I never would have thunk it. All right, this one completely on your own. No talking, no friends. Make sure you identify any missing terms. How did you get that? I don't know. I guess it's a big. Okay. You know, I'm just not this. I need to learn. It's like this should have a sheet. So it's like I need to do that. It's maybe I'm doing it wrong. So can't do it right. I'm breaking this one. I should do so. That's it. Exactly. Uh-huh. Yep. Okay. Let's talk about this shortcut of evaluating polynomials. All right. So, we have our -2. What was I missing? The square. So this one had to be a 0. And we get it going. -2 and 1. 9 and -2. -2 and 7. 0 and -14. A negative times a negative is a -9 and 28. -2 and 19. And 2 and -38. So therefore, P of -2 equals, yay! Yes? Are we okay? We don't hate it?